All right, we're still continuing with section 1.1. Now we're going to talk about set builder notation. Set builder notation is a little bit different. We are going to use the braces with set builder notation. And we might end up using expressions, or we might end up using words, or a combination of expressions and words. So another way to represent intervals is set builder. We've got interval notation, now we've got set builder notation. Set builder notation uses symbols to define a set of terms of the properties of the members of the set. Lots of prepositions in there. So here's how it works. You might have something in set builder notation like it's shown. You've got the braces, you got the brace open, then you got an X, then you got a vertical line, then you got X, then you got a less than, then you got a B, then you got to close the brace. So that opening and first letter, that defines what variable you're working with. So that's the set of all real numbers X. So that says what your set is called. Things that are called X. Okay. Then you have that vertical line. That's the such that. And then you have what X, the set of X can be. X is less than B. So you could write it in words, you could write it in symbols. As long as you put it in the braces and put that X vertical line, you've got some set builder notation. So they gave us some examples here. All real numbers X such that X is less than or equal to A, or X is greater than or equal to B. And the or in the middle and the and in the middle make a difference. We want to make sure we know that. And is where are they together, or is where are they not together. Okay, so not together. A can be, because we got the line underneath equals and goes down. B can't be, got the circle and goes up. So that'd be an or situation because it's not where they're together, it's where they're separate. The next one, all real numbers X such that X not equal to A. So it can be anything but A. So we'd circle where A is, and then we get to go every which way but A. So it goes right forever and left forever. So let's practice some of these. First, let's practice sketching what the set builder is telling us. So we're going to kind of work our way backwards. We're going to be given the set builder, and we're going to draw the picture of it. So I'm going to do a number line. And what this says is all real numbers X such that 2 is less than X, which is less than or equal to 5. So I need 2 and 5. I did not want to stop recording. We're going to put 2 and 5 on there. So I'll put 0, 1, 2, 3, 4, 5, 6. Okay. It cannot be 2, so I'm going to put a circle. It can be 5, so I'm going to color in a dot. I'm greater than 2, and I'm less than 5. So I'm all of this stuff right in here. Just like that. You could draw it on the number line. I like doing it above so I can tell the difference, because sometimes the lines are the same thickness and you can't tell where you colored in or not. It's like going above it. Let's look at B. All real numbers X such that X is less than or equal to 0, or X is greater than or equal to 4. These are probably going to be going in opposite directions. So if we draw this on here, let's see. -1, whoops, undo, redraw. -1, 0, 1, 2, 3, 4, 5. Okay. I've got less than or equal to, so I'm going to color in on 0. And I can go less, which is to the left. And I'm going to circle around 4, because I can't be 4, but that's where I start, and I go greater, so that's to the right. So that's interpreting set builder notation into a pictorial graph. Now let's look at example number 3. Example number 3 is we're going to take what they give us in words or in symbols or in a picture, and we're going to write that into set builder notation. Don't know why that's on there. So let's look at A, the set of all integers greater than 5. And we got a little note out here, understanding mathematical terms. The symbol and that funky looking E denotes membership in a set. The expression X with the funky E, Z, remember if we go back to the levels of sets of numbers, Z is integers, means that X is a member or an element of the set of integers. So when we write that X is included in Z, the integers, and they like to do the double line Z, we could do it that way. Here, there. I cross my Z so they're not 2's though. Okay, so X is in the set, excuse me, is in the set integers. That's part of it, right? Because we got the integers part. And it needs to be greater than 5. So X needs to be greater than 5. It doesn't say greater than or equal, it just says greater. So we're going to write it just like that. So in set builder notation, we do the brace, all real numbers X, such that X is an integer. That funky Z. And X is greater than 5. And that's all it takes. You always have to just put that X, all real numbers X, such that, and then you put in what is inside all that set of real numbers. Okay, unless it includes an imaginary number, then you wouldn't put the real numbers part, but that's what it typically means. So let's look at B. So this is interval notation. It's telling us it goes from negative infinity to negative 1, but doesn't touch 1. Or it goes from negative 1 to positive infinity, but it doesn't touch 1. So it looks like this in a picture. Don't touch it, but then we go this way. And don't touch it, and we go that way. So in set builder notation, we get to be anything except negative 1. So if we open our brace, it's a really crappy brace, but you know what I'm talking about. All real numbers X such that X is not equal to 1. And we close it. Now, give it a pause and give these 4 a try. The first 2, you're going to sketch the graph of what the set builder tells you. The last 2, you're going to write it into set builder. All right, let's look at number 4. All real numbers X such that it's negative 6 less than X less than or equal to negative 2. So I need a number line. Negative 6 is on there, negative 5. 4, negative 3, negative 2, negative 6, can't touch it, draw a circle. Negative 2, can touch it, draw a dot. And it looks like X is in the middle. So X is greater than this one, so it goes this way. X is less than or equal to that one, goes this way. So it's everything connecting in between. Okay, number 5. All real numbers X such that X less than or equal to 0 or X is greater than or equal to 10. Most likely they're going to go the opposite ways. Okay, so we got to get 0. I'm going to do it by 2's this time, so I saved me some space. It can be 0. It's less than or equal to 0. Less than goes this way. And it can be 10. And it's greater than or equal to 10, so it goes that way. They're pushing opposite directions. 6. Let's see. We can start at negative infinity, comes all the way to negative 1 and includes negative 1, or start at 1 but can't touch it and goes to infinity. So we want to write that as a set builder. So I'm going to draw a picture of it first. I don't have to. I just want to see what's going on. So, whoa, undo those. Back to the pen. So we got -1 and we got 1 on the list, and there's a 0 in the middle of those. So I can be -1 and I go to negative infinity, or I can't be 1 and I go to positive infinity. Okay, so all real numbers x such that x is less than or equal to -1, or, because this is where they're not touching, so it's an or instead of an and, or x is greater than 1. No equal on that one because you can't touch it, and then close your brace. And lastly, number 7, the set of all integers except 4. So if I drew a graph of that, don't have to, but I'm going to look at it picture-wise. Can't touch for -4, but I can do everything this way, and I can do everything that way. So the set of all real numbers x such that x is not equal to 4. Close it out. So set builder notation using braces, interval notation using parentheses or brackets. Brackets, you can be it. Parentheses, you can't be it. Don't touch.